All right, so in this video we're looking at trigonometric ratios. Trigonometry, we can simplify it down to, shorten it down to just trig. That's usually what we talk about. We could spend an entire school year talking about trig. There's an actual class that's called trig. And trig just mainly just focuses on right triangles, and that's what we're going to see here. We're going to be focusing on right triangles, triangles with a 90-degree angle. These are brand new operations, so it's really, really important that you focus on this operation. This operation, you are going to see an integrated 3. If you go into pre-calculus, calculus, this is huge. This is one of the biggest things. If you only watch one set of videos and really focus on one set of videos, this is the videos. This one, the next one, potentially the one after that. Those are the ones you want to watch. Those are the ones that you're going to be using quite a bit, and this will get you where you need to be for your future math class come fall, whenever it is that we start school. The ratios that we're going to see, it's important that we understand that they are operations, just like adding is an operation. So I want to make sure that we've got that concept down, because the operation is actually with words, not a symbol. So I want to do something real quick before we get started. So when we do just addition, we have no problem with addition. If I said 5 plus 8, we know that adds up to 13, but we don't really understand why and what that means. The plus sign there, that's the operation. Right? That sign disappears as we do the problem. You notice the answer doesn't have any plus sign in it at all. It shouldn't, because you're adding things, and that sign is telling you what it is you need to do. We see that sign, and that triggers, hey, I'm supposed to take the 5 and the 8, combine them all together as one big giant number, and we get the 13, right? The 5 disappears, the 8 disappears, and we don't ever think about that. We just go, yeah, that's normal, right? But then we do new math stuff, and we suddenly throw all that out the window, and we think things have to happen a certain way that don't have to happen here. So I just want to point that out, because I'm going to bring this idea back a bunch of times as we go through things. So let me get rid of that. What we're going to need is, we're going to need a right triangle. So let me get a right triangle in here. And poof, like magic, there's our right triangle. Notice I've labeled up the 90-degree angle there, as normal. We've got the angles labeled with letters A, B, C. Notice they're capitals. It's typical that we use capital letters for corners. Get in that habit. That's good math practice. The sides, when you're naming a side, and we've gone over this before, but it's been a while. It's been a while since we've just been in school. The side that's opposite the angle is usually named the same letter. So if you look at angle C, the right angle, if we were to go opposite angle C, if we were standing on angle C and look directly across, we see that side directly across from it, the slanted side. That's the hypotenuse of this triangle. Let me get rid of that arrow. We would call that side lowercase c. I know it's hard to tell between a lowercase and an uppercase c, but that would be the case. Going across angle B, if we look directly across from angle B, we would see that side, and that side we would label with a little b, because it's a side, and this side would be little a. Okay, so the lowercase letters are the sides, and the uppercase letters are the angles. It's very, very important that you have those separated. If you always write in uppercase or always write in lowercase and you don't do the other, math can get even more confusing than it already is, because in math, uppercase letters usually stand for one thing, and lowercase letters typically stand for another, and it's not uncommon to see an equation that has both upper and lowercase letters, and they mean different things. So it's very important that you are okay with that. So we're going to look at 3 different functions. Just like adding is a function, taking a square root is a function, multiplying is a function. Those are all functions. Those are all operations that affect numbers. These new operations that you've never seen before are going to affect numbers as well, and affect certain types of numbers. So the first function that we're going to look at is a function called the sine function. This is a brand new word for you, S-I-N-E, the sine function. Imagine back in like the 2nd grade, even earlier than that in kindergarten, we talked about adding. We said, what the heck is adding? What does adding mean? And you had to figure out what the word add meant and what the symbol meant and things like that. This is the same thing. This is a brand new function for you. And so we have to accept the fact that it's brand new, and it's something that we have to put a little work into to understand. It's not a difficult concept, but it can be difficult because students tend to make it more difficult than it actually is. So let me define it for you, the sine function. So let's get the definition up here. All right, so again, poof, like magic, there's the definition, the sine function, the sine of an angle, of angle A, and we can do any angle we want, but it's really important there here in the beginning to note that when we do this sine operation, it's always the sine of an angle. You can't do the sine of a side, you can't do the sine of just a regular number. Anytime you're going to do the sine operation, it has to be of an angle. It's like adding, right? Adding, we have to add numbers together or add things that are like numbers. X plus 3x we can add together because they're like numbers. I can't add apples and oranges and come up with a whole brand new fruit. It doesn't work. Orpals, right? That's not it, right? And so when you're adding, it's just certain things that can be added together. Sine is another operation. It's a brand new operation. And when we do this sine, we're always looking at an angle. And what it means, if we look at this definition, it says that the sine is the ratio. So now let me keep that highlight there. Let's just do a different highlight color. So ratio. What the heck does ratio mean? Ratio is just a comparison. It's a fraction. It's comparing two things. If we were to say the ratio of boys to girls in the class was 10 to 12, then that means that there are 10 boys in class and 12 girls in class, or at least they're in that ratio. We could have 20 boys in class and then we would have 24 girls in class, right? That still preserves that ratio. If we say something's in the ratio of 1 to 2, that means for every one of one thing we have two of another. That's all a ratio is. It's a fraction. Okay? And so what are we comparing? We have to compare two things. We need a numerator and a denominator. In the numerator is the length of the opposite side from angle A. And then the other part of the fraction, the denominator of the fraction, is the hypotenuse. Okay? So when we look at all of those, we can shorten this up. In math, we shorten things up, right? We've been seeing this for a long, long time. I don't want to have to write, find the sine of angle A, or I don't want to have to write, find the ratio of the length of the opposite side of angle A compared to the hypotenuse. Why write all that out? That's why we have this function. This function takes all those words and puts it just into one little simple operation. Here's the function for sine. If we want to write out the function for sine, that's the function. Okay, sin. But we don't say sin, we say sine, because it means sine. Okay, that is an operation just like writing this. That's an operation. That means to add, just like writing this. That is an operation. That means to take the square root. Math is full of operations. Does this square root symbol, does this have any meaning by itself? No. It has absolutely no meaning. If I wrote that on a test and said, hey, solve this, you'd be like, Krieger, you're missing something, right? There needs to be a number here. If we put a 25 in there, yeah, now I can do it. But without that 25, that symbol means nothing. We can't evaluate it. Same deal. This symbol means nothing by itself. It's just like writing a plus sign. If I just wrote a plus sign and said solve it, you'd be like, Krieger, what am I supposed to add? I don't get it, right? We'd be confused. For some reason, we don't get confused by writing that. We should. That should be just as confusing writing SIN than writing just a square root symbol. You can never write just SIN. That's the operation. If you're going to write SIN, you need something after it. The thing that you put after it is always going to be an angle. And so we always do sine, and then in parentheses, we put the angle that we're looking at there. Maybe the angle has a letter name. We're going to put a letter there in a second. Maybe the angle has an actual measurement. We'll see that too as we go through some of these notes. So it's really, really important that you can't just write SIN and think that you're doing something. That's writing a square root sign. You're not doing anything by just writing a square root sign. So let's get rid of that plus and that square root sign, and we're looking at the sine of an angle. And so according to this, I'll get rid of the word angle as well. According to what I have written up here, we want to do the sine of angle A. Okay, no problem. So SIN represents the fact that I'm going to do the sine operation, and angle A, ooh, I don't like that yellow, I'll go back to black. The sine of angle A would just be written like that, sine of A. There's nothing I can do with that. This has no, like we had 5 plus 8 before, I can put that together and make it a 13. When I see this, without a picture, without any other information, there's nothing I can do. Because I have a picture, I can go up to the picture and I can take a look. And so when I look at the picture, I need to focus on angle A. That's really, really important that you focus on the right angle. Because it says sine of A, I want to focus on that angle, angle A. Everything is going to be based on that angle. I don't care about angle B, I don't care about angle C, I care about angle A. So based on angle A, there are 3 sides. one side, it does not matter what angle you're focusing in on. One side is always going to be labeled the same thing every time, and that's the hypotenuse. You can't change the hypotenuse. We've talked about the hypotenuse before. The hypotenuse is always going to be the biggest value. The hypotenuse is always going to be the biggest side. It's also always going to be across from the 90-degree angle. And so we need to lock that one in right away. If we look, it says that the sine of angle A is the ratio of the length of the opposite side. So there are two other sides besides the hypotenuse for every right triangle. A right triangle always has a hypotenuse, and then a right triangle has two other sides. It has, if we look at one angle, it'll have an angle side opposite to the angle, and then we'll also have another word, a side adjacent to that angle. Going opposite is just looking across. We know what opposite means, so side A is going to be the side that is opposite angle A. This is only if we're talking about angle A. We're going to switch, and we're going to look at angle B next, and when we look at angle B, some of these words are going to change, but that's going to be our opposite side. Side B, that side is adjacent to A. Adjacent means next to, so side B is next to angle A. Side B touches angle A, and that's why we call it adjacent. Side C does as well, but C has a special name. It's called the hypotenuse, and so we don't call that one adjacent. So when we look at our function down here, the sine of angle A, the sine of angle A is going to equal the length of the side opposite to angle A. The side opposite angle A is little a, compared to, so divided by, as far as the fraction is concerned, the hypotenuse, and the hypotenuse is C. So the sine of angle A is equal to just A over C. Say A is 7 and C is 12. That would be 7 over 12. We will look at an example before we're done here. There are two other ratios that we need to look at, and I'm going to put both of those up here now. All right, so the second one that we have is called the cosine. Looks just like sine of angle A is the ratio of the length of the adjacent side to the hypotenuse. So going much quicker through this one, I don't want to write out the whole word cosine, so what we do is just use the first three letters, cos, cos. It means cosine. We should say that as cosine and not cos. We need something after it, just like sine. We put the angle after it. Since we're doing the cosine of angle A, we'll do cos A. Sometimes put that in parentheses, and sometimes we don't. It's not needed. It's going to equal a ratio. A ratio is a fraction. What's going to be in the numerator of the fraction? The side that is adjacent to angle A. If we go back up to the picture and look, the side adjacent to angle A is side B, divided by the length of the hypotenuse, and the length of the hypotenuse is C. So just like with sine, it's just another fraction. We have one more that we need to look at. Finally, we have the tangent operation. The tangent of an angle. Angle A is the ratio of the length of the side opposite angle A compared to the length of the adjacent side. So when we're writing this operation, we don't write out the full word, just like we didn't for the others. We just use the three letters. So sin for sine, cos for cosine, tan for tangent. We're going to do the tangent of angle A. You have to put something after that. It's just like writing a square root sign if you don't. And that's going to equal a ratio, which is a fraction. What's going to go in the numerator of the fraction? The side opposite angle A. Well, the side opposite angle A, the length of that side is little a, divided by the side adjacent to angle A. The side adjacent to angle A is little b, and so that would be the tangent operation. So whatever those numbers are, whatever the values of those sides are, we would put those numbers there, and we would have a fraction. The sine of angle A would equal a fraction, the cosine would equal a fraction, the tangent would equal a fraction. We will get to examples in our next video, and we will see that. The way that we remember them, that's the last thing we're going to do in this video, the way that we remember which one is which is you can remember this mnemonic device. A mnemonic device is a way to remember certain things, and sometimes we use a device, we'll create a sentence. Please excuse my dear Aunt Sally. This, we just create a word, SOHCAHTOA. SOHCAHTOA basically tells you what it is that you need to do these operations. S stands for sine, O stands for opposite, H stands for hypotenuse. So the sine function is the opposite side divided by the hypotenuse. CAH tells us that the cosine function is equal to the adjacent side divided by the hypotenuse. And then finally, TOA tells us that the tangent is the opposite side divided by the adjacent side. Our next video will have some examples, and we'll go through a whole bunch of things. We're going to compare this to 45, 45, 90, and 30, 60, 90. So we got quite a few more things that we need to cover. So head on to the next video to see how SOHCAHTOA is going to be used.